So an inequality is a math sentence that compares quantities. We solve inequalities the same way. So yeah, these inequalities, they're going to look like regular equations, but there's only one exception when we solve them, okay? And that's if at the very end of the problem, you get to the end and the coefficient is negative, just the coefficient. If it is negative and we have to use multiplication or division principles of equality on that negative, it will flip the sign. And the reason that is because negatives are opposite, so it's going to flip that sign. There's more reasons to it, but I also assume you don't care. Okay, so again, here's the symbols. We're going to see these with a little bit of wordiness to them. So if you see fewer than, notice fewer than doesn't have the equal sign with it. That's because it can't actually be that value. Now, the values that we compare, whether we're using less than, greater than, less than or equal to, or greater than, we'll need to keep in mind that the values we're comparing these to and solving for, that's a transition from truthfulness to falsefulness or the other way around, okay? So that's why we need those kind of endpoints on these, which is related to the graphs. It's because that's where it does make that transition. So again, sometimes the value is not exactly true. Like if I compared, if I said x is, like we said, x is less than 5. 5 doesn't make that statement true, but 5.000001 does. No, sorry, there we go. I went the wrong way. 4.999999. Okay. So no, that would be true. Yeah, okay. So translate the phrases below into inequalities and interval notation. Use the variable x for the inequalities. Okay, so it says up here, it says at least 15. So it says to use x, by the way, so I'm comparing x with 15. So if x is at least 15, the first thing that I kind of go through in my mind when I'm comparing these is, first, can it actually be that value? So if I said at least 15, could x equal 15? And the answer is yes. It could be, okay? Now, since x has to be at least 15, that's the smallest value that it can be, which means that beyond that, it needs to be bigger than 15. So I need this to be eating the x. If you like alligators eating the bigger value, that's fine. But I usually look at it a little different, okay? So if I wanted to show in interval notation that x is greater than or equal to 15, then I would have to show that starting at 15, right? Because x is everything bigger than 15. On a number line, that would be everything to the right of 15. Would say, all right, starting at 15, technology's already going haywire. I'd have to say it includes the 15, and that's what we use. That's when we use a square bracket like this one. But then we got everything beyond 15, which means it's going to go to infinity. Okay, so this would be the interval that represents at least 15, or x is greater than or equal to 15. Okay, so again, I'll do every other one for now, but more than 13. Okay, so I'm comparing x with 13, some value, and 13. Now, again, for me, I say, could it possibly be equal to 13? If it's more than 13, it cannot be exactly 13, not exactly. So I would have to show here that x needs to be bigger because more than, so I need a greater than symbol here. Now, comparing that to the last one we did there with at least 15. Okay, so again, 13 here is the transition. It's kind of my smallest point here. Because x it can't be exactly 13. So that's going to tell me, let me do it this way, that we got an open parentheses here. Okay, because the open parentheses says it can't be that value that we're showing. But like we know, it should be everything on the number line, it would be everything to the right of that. So this is where we say, again, this will go to infinity. And you'll hopefully notice that we never actually include infinity. So even up there with the 15, I used the parentheses. I used the parentheses here because we can never include infinity in a value because it's not defined. It's a value that's so large, it's growing even now. And as far as I know, there's only one person that's ever counted to infinity, only one, that I know of. Do you guys know
Who would that be?
who it is? It's Chuck.
Is it you?
It's Chuck Norris. Actually, he did it twice. So. All right, this next one, it says strictly between 10 and 11. So if it's between 10 and 11, that means that I cannot include it, 10 and 11, with this next inequality that I'm going to show. So now again, it's got to be between 10 and 11. So I'm going to compare x. I'm going to put 10 on the left because it's the smaller number. I like to put the smaller one on the left, and then the bigger one on the right of that value x. Now in comparing, I'm just going to compare x with 10. It says between 10, so that means x has to, the 10 is the smallest value, so it has to be bigger, but again, can it be equal to that 10? Since it's between, it cannot actually be equal to the 10, and so I'd have to say that first here, that 10 is less than x. Now if I were to compare x with 11, because it says it's between 10 and 11, 11 is kind of the maximum value there, or the biggest value that we can have. But again, can it equal 11? And the answer is no, so I have to say that it would have to be less than 11 as well. So this is what we call a compound inequality because it's comparing two values at the same time, which is okay, we can do that. Next up, we want the interval there. So we know we're, by the way, this is okay to just start here. I know I'm going from 10 to 11, everything between there is okay. 10 though cannot be included, so I have a parentheses. 11 also not included because, and so we have parentheses. But why is it not included? It's because, again, over here, there's no equals with my inequality parts there. And then last up, we got no more than 17. So again, I would compare x with 17. So it says no more than 17. Could that equal 17? And the answer is yes. So it could at least equal 17. But since it can't be more than 17, that means 17 would be a maximum there, meaning that x should be everything less than 17 as well. All right, so how are we going to do this interval? Well, I know 17 is a transition point, right? But 17 is also a maximum, so that means that everything on the number line, if we were to show that, everything to the left of 17 would make this true. So I would actually, it's not infinity here, it's negative infinity, which is never included. 17 is included though, so we'd have to show a square bracket there. So yeah, I'll specify that here too. So yeah, there's a difference between the positive and infinity. This would go all the way to the right, negative infinity would go all the way to the left. And yeah, I'll clarify this too. These do look like ordered pairs, which is unfortunate because we just kind of got done with some ordered pairs, at least the ordered triples, right? So yeah, please don't get these confused with those because they're I hate to say it, but they're different, right? So this is interval notation. Again, this is an interval which communicates the same thing as this inequality. It's saying starting at 13, which is not included, everything to the right, all the way to infinity, which is also not included, would make this statement true. Just stay on this purple one. What are some values that are bigger than 13? 20? 13.00001? 200 trillion? I don't know, something like that. All right, this next one where it says at most 14. So we are comparing x with 14 right here. But again, it says that it's at most that 14, which means it could be equal to the 14 because that would be its mostest. But 14, x cannot be as big as that, so it has to show that it will be less than. So less than or equal to there. And then our interval for this one will need to show that 14 is the biggest value, and that means it would go all the way to negative infinity, which is never included. But the 14 is included, so we're going to have to put in a square bracket there. Now it says, on this next one, it says fewer than 12, so we're going to compare x with 12. And here, we'll say that fewer than 12 means it cannot equal 12, but it has to be fewer than or less than the 12 there. Okay, so that means 12 would be the maximum value, and that means also it could go as far to the left as negative infinity, which is never included, but here 12 is not included either, so we have a closed parentheses there. Now this next one where it says it's between 10 and 16 inclusive means that the 10 and the 16, when we compare that to x, would need to be included because it says inclusive there. So that means it could equal 10, but also it could equal 16. That has to be somewhere in between there. So it needs to be bigger than the 10, but also less than the 16. And that would be our interval. And then we know that it has to be between 10 and 16, both of which are included. So we got square brackets with 10 and 16. And again, as much as this looks like an ordered pair, it is not.